Alright, in this video we're going to go through two examples where we're trying to write the equation of a rational function with some different characteristics. So the first one's just going to be written out, here's the characteristics, and the second one is going to be from a graph. Alright, so we're just going to dive right in. Remember, it's an equation of a rational function, so it better have an equal sign. So I'm going to start it off by just writing r of x equals. I always use r of x, or I usually use r of x. You could write f of x or just y equals. And we know it's going to take this shape where it's going to have one polynomial in the top, in the numerator, and a polynomial in the denominator. And I need to use my clues here to decide what that is. Remember, I have to write it as one fraction. I can't just like add a bunch of other stuff over here. Otherwise, it's not a rational function. It's got to fit in this form. Okay? So, it's got vertical asymptotes at x equals 2 and x equals 12. And the way we get vertical asymptotes are from the denominator. So these turn into factors in the denominator that look like this: x minus 2 and then x minus 12. Because at 2 and 12, if I plug those in, I would get a 0 in the denominator, so it would create a vertical asymptote. I want to also make sure that those factors don't repeat in the numerator. Alright, a horizontal asymptote at y equals negative 7. A horizontal asymptote happens when the degree of the numerator and the denominator match. So the degree of the denominator right now is 2. My degree of the numerator needs to be 2, and then the leading coefficients. So whatever the leading coefficient of the numerator divided by the leading coefficient of the denominator is, that number will be that'll be the negative 7. So I'm going to put a negative 7 up here, and then I'm going to make sure that my degree, when I do write this out, ends up being 2 so that the degrees match. Alright, so that's for the horizontal asymptote, and then the x-intercepts at the point 3, 0 and negative 4, 0. Very similar process to what we did in the vertical asymptotes. I'm going to take x minus 3 and write a factor because of this x-intercept there, and then x plus 4 because of this x-intercept here. If I were to set this equation equal to 0 and solve for x, I would get 3, 0 and negative 4, 0. Well, 3 and then negative 4, and that would be my x-intercepts. Everything matches up, and that's it. That's all you got to do. That's how you put it all together. Essentially, we're going to do the same thing with the graph. Now, I printed this out. Hopefully, this will be in frame for you. Given the graph, write a possible equation of a rational function that could match this graph. All right, so I acknowledge that maybe there'd be more than one that kind of looks like this or similar enough. Without a graphing utility, how would you do that? Well, what you would need to do is you would need to take note of some of the key features in the graph. Essentially, the same thing we did before. So like this vertical asymptote is the equation x equals, what's that, negative 7. And this vertical asymptote is x equals 2. This horizontal asymptote is y equals 3. So I'm just putting together what I had done in example 1. I've got two x-intercepts at negative 5, 0 and 0, 0. And I'm going to try to put this together. So let's start off. Let's write our rational function here. So we've got r of x equals, it's going to be in this form. Alright, so let's start with our vertical asymptotes in the denominator, because we kind of know what those have to look like. So since there's one at negative 7, pardon me, I'm going to have to write x plus 7. Since there's one at 2, I'm going to write x minus 2. Alright. And then, let's see, I need a horizontal asymptote at y equals 3. So that means I need to put a 3 up here, and my degrees need to match. The degree of the numerator and the denominator need to match. So the degree of the denominator right now is 2. My degree of the numerator, let's see, the degree of my numerator needs to be 2 as well. Okay. So let's write these factors for these x-intercepts. Factor for that one will just be x, or x plus 0. And that's it. If I typed that into Desmos and checked, it should match this, at least close. It has all those key features. That's all I'm really looking for. And yeah, I guess there's other options. You could write 6 over 2, but that would certainly simplify to 3. But that is it. I hope that helps you.